This story will take you on a journey through the wonders of the universe, from the birth of stars to black holes to the mysteries of distant galaxies. If you enjoy listening, don't forget to like this video and subscribe for more cosmic stories. Part 1. The Silent Beginning. Far above us, beyond the clouds, beyond even the thin blue line of our atmosphere, stretches the endless sea of space. It looks silent, almost empty, when we raise our eyes to the night sky. But in reality, the universe is alive, full of energy, light, and stories written across billions of years. Every star you see is not just a shining point of light. It is a world, a history, a time machine glowing in the darkness. Astronomers believe our universe began nearly 13.8 billion years ago with the Big Bang. Not an explosion in the ordinary sense, but the sudden expansion of space itself. Imagine the entire cosmos compressed into something smaller than a grain of sand, and then, in less than a heartbeat, swelling outward faster than light. From this moment, space, time, and the very laws of physics were born. In the first seconds, the universe was unimaginably hot and dense. Protons and neutrons began to form, the building blocks of atoms. Within minutes, hydrogen and helium appeared, the simplest elements, destined to become the fuel of stars. For hundreds of thousands of years, the universe was filled with a glowing plasma, a fog of particles and light so thick that nothing could travel freely. It was not until about 380,000 years later that the fog cleared, allowing light to escape for the first time. That ancient light, known today as the cosmic microwave background, still travels across the universe, a faint whisper from the dawn of time. Billions of years passed. Slowly, under the pull of gravity, gas gathered into great clouds. Within these clouds, the first stars were born. They ignited like cosmic lanterns, pushing back the darkness of the early universe. These stars were massive, far larger than our sun, and they lived fast, burning their fuel in only a few million years before exploding as brilliant supernovae. Their explosion seeded the cosmos with heavier elements, carbon, oxygen, iron, the ingredients of planets, oceans, and even life itself. And so, the universe began to take shape. Galaxies spun into being, clusters of stars bound together by gravity, forming magnificent spirals and giant elliptical forms. Among these galaxies, billions upon billions of stars were born, each one a possible sun for a future world. Our own Milky Way, a graceful spiral stretching more than 100,000 light-years across, became one of these homes for countless stars and mysteries. Deep inside one of its arms, about 4.6 billion years ago, a small star lit up, our Sun. Around it, a disk of dust and gas swirled, slowly clumping together into planets. Among them, one tiny blue world formed, covered in oceans and skies, destined to become home to us. But before Earth, before life, before humanity, there was only silence, stars, and the vast story of space itself. Part 2. The Birth of Stars. The story of stars is the story of creation itself. If you're enjoying this journey through the universe, remember to like this video and subscribe so you don't miss the next chapter of Cosmic Wonders. Far across the galaxy, in vast and silent regions, lie immense clouds of gas and dust. To the human eye, they might look like empty black patches against the stars, but in truth, they are nurseries, places where stars are born. Astronomers call them nebulae. Within these clouds, gravity is at work, pulling hydrogen atoms closer and closer together. As the gas clumps, the temperature begins to rise. The cloud darkens, tightens, and slowly begins to glow. It can take millions of years for a star to form, but once the process begins, it is unstoppable. At the heart of the collapsing cloud, a core grows denser and hotter, until finally, at around 15 million degrees Celsius, something extraordinary happens: nuclear fusion. Hydrogen atoms fuse into helium, releasing enormous amounts of energy. A star is born, blazing into the darkness. The first breath of a star is like the first cry of a newborn child. For the first time, the surrounding darkness is pushed away, and light fills the region. If you were nearby, though no human ever could be, you would see waves of radiation sweeping across the nebula, sculpting its edges into pillars and arcs of glowing gas. What looks to us through telescopes like delicate cosmic art is actually the raw, powerful breath of newborn stars. The life of a star depends on its size. Small stars, like red dwarfs, burn their fuel slowly, glowing faintly for trillions of years, far longer than the universe itself has existed so far. Stars like our Sun live more balanced lives, shining steadily for billions of years before gently expanding into red giants and casting off their outer layers. Massive stars, though, are impatient. They burn with ferocious brightness, consuming their hydrogen in just a few million years. Their deaths are spectacular supernova explosions, some so bright they outshine entire galaxies for days. These explosions are not just endings, they are beginnings. When a star dies, it scatters the heavy elements it created in its core into space. Carbon, oxygen, nitrogen, iron, even gold and silver. Every atom of calcium in your bones, every molecule of oxygen in your lungs was forged in the heart of a star that lived and died long before the sun was born. Carl Sagan once said, "We are made of star stuff," and it is not poetry, it is scientific truth. Star death also leaves behind strange remnants. Some massive stars collapse into neutron stars, incredibly dense objects where a teaspoon of matter would weigh billions of tons. Others go further, collapsing into black holes, places where gravity is so strong that not even light can escape. And yet, as some stars die, others are born. The cycle never ends. Across the Milky Way, thousands of stars ignite each year, while countless others fade away. It is a cosmic rhythm, the heartbeat of the universe, continuing without pause for billions of years. When you look up at the night sky and see those tiny points of light, you are witnessing this cycle in motion. Some of those stars are still young, barely beginning their lives. Others are ancient, burning through the last of their fuel. And some may already be gone, their light only now reaching us across the emptiness of space, carrying with it a story billions of years old. Part 3. The Dance of Galaxies. The universe is not still. If you're enjoying this cosmic journey, don't forget to like the video and subscribe. More space stories await you among the stars. When you look up on a clear night, you see the Milky Way stretching across the sky like a river of light. What you are seeing is just one spiral arm of our galaxy, home to more than 200 billion stars. But the Milky Way is not alone. It is part of an enormous cosmic community with billions of galaxies scattered across the observable universe. Each one is a magnificent city of stars, dust, and mysterious dark matter, bound together by gravity. Galaxies come in many shapes. Some are elegant spirals, their arms winding gracefully like a whirlpool of light. Others are massive ellipticals, shaped like glowing spheres filled with old stars. Still others are irregular, twisted, and chaotic, sculpted by collisions and cosmic accidents. And yes, galaxies do collide. When two galaxies meet, they don't crash like cars on a highway. The vast distances between stars mean that direct collisions are rare. Instead, their gravity pulls and stretches them, twisting their shapes into long tidal tails of stars and gas. Over millions of years, the galaxies merge, creating a new, larger galaxy. It is a slow, silent dance, choreographed by gravity, performed on a stage billions of light years wide. Our own Milky Way is part of this cosmic ballet. In about 4 billion years, it will collide with the Andromeda Galaxy, our nearest large neighbor. Already, astronomers can see Andromeda approaching at 110 kilometers per second. When the two galaxies meet, their stars will swirl into new patterns, their black holes may merge, and a new galaxy will be born, sometimes called Milkomeda. To anyone living on Earth, then, the night sky will look unimaginably beautiful. Andromeda filling the heavens, its stars mingling with our own. Galaxies don't just dance with each other. They gather into families called clusters, held together by invisible webs of dark matter. Some clusters contain thousands of galaxies, all orbiting a common center of mass. Even these clusters are not the end of the story. They themselves gather into superclusters, forming a vast cosmic web that stretches across the universe. When mapped, this web looks like a giant sponge or neural network with filaments of galaxies threading through immense voids of emptiness. One of the humbling truths is that galaxies are not eternal. Over billions of years, star formation slows down. Gas is used up and new stars no longer ignite. Galaxies grow old, fading into quiet collections of red and dying stars. Yet even in their silence, they remain monuments of the universe's story, relics of creation still glowing faintly in the dark. So the next time you see the hazy band of the Milky Way above you, remember that it is not a static picture. It is moving, evolving, part of an endless cosmic dance. Every star in the sky is taking part in that choreography, moving with gravity's rhythm, step by step over eons of time. Part 4. The Mysteries of Black Holes. The deeper we look into the universe, the more it challenges our imagination. If this story keeps you fascinated, don't forget to like the video and subscribe. Many more cosmic mysteries are waiting to be told. Black holes are among the most mysterious and powerful phenomenon in existence. They begin with death, the death of a massive star. When such a star has burned all its fuel, its core collapses under the crushing force of gravity. If the core is heavy enough, no force in the universe can stop the collapse. Matter is squeezed into a point of infinite density, a singularity, hidden behind a boundary we call the event horizon. Beyond that horizon, nothing, not even light, can escape. At first, the idea of black holes seemed like science fiction. Even Albert Einstein, whose equations predicted them, doubted they could exist in reality. Yet over the decades, astronomers have gathered overwhelming evidence. We have watched stars orbiting invisible points, pulled by gravity so strong it could only be a black hole. We have detected the ripples of space-time, gravitational waves, created when two black holes collide. And in 2019, the impossible became visible. The Event Horizon Telescope gave us the first image of a black hole's shadow glowing orange against the darkness. Black holes come in different sizes. Some are just a few times the mass of our Sun, the remnants of collapsed stars. Others, called supermassive black holes, sit at the centers of galaxies, weighing millions or even billions of solar masses. Our own galaxy, the Milky Way, has one, Sagittarius A*, a giant 4 million times the mass of the Sun, hidden behind clouds of dust 26,000 light-years away. What happens inside a black hole is one of the greatest unsolved mysteries of physics. General relativity, Einstein's theory of gravity, says that everything is crushed into the singularity. Quantum mechanics, the science of the very small, says that information can never truly be destroyed. Reconciling these two truths is one of the deepest puzzles in science. Even stranger, black holes are not entirely black. In the 1970s, Stephen Hawking showed that black holes can slowly lose energy through a faint glow now called Hawking radiation. Over unimaginable timescales, trillions upon trillions of years, even the largest black holes will eventually evaporate, leaving behind nothing but whispers of radiation. But perhaps the most breathtaking idea of all is that black holes might not be an end, but a doorway. Some theories suggest that what falls into a black hole could emerge elsewhere in the universe, or even in another universe entirely. These remain speculations, but they remind us how much we still do not know and how vast the mysteries remain. To gaze into the heart of a black hole is to look into nature's most perfect paradox, a place where time stops, space folds, and the rules of physics themselves seem to break. Yet black holes are not monsters destroying the universe. In fact, they may be essential to its structure. Astronomers believe supermassive black holes help galaxies form, shaping the very stars and worlds around them. The same objects that consume light might also give birth to the cosmic order we see around us. Part 5. The Search for Other Worlds. The night sky is full of stars, but how many of them have worlds like ours? If you're enjoying this journey through the cosmos, don't forget to like this video and subscribe. More stories of space are waiting for you. For most of human history, Earth was the only known planet. The sun, the moon, and the stars seemed eternal and unreachable. Even the planets of our own solar system, Mercury, Venus, Mars, Jupiter, and Saturn, were mysterious points of light slowly wandering across the heavens. But everything changed in the last few decades when astronomers discovered something extraordinary. Planets are everywhere. These planets beyond our solar system are called exoplanets. The first confirmed detection came in 1992 when 2 tiny worlds were found orbiting a pulsar, the remnant of a dead star. A few years later, in 1995, astronomers announced a giant planet orbiting a sun-like star called 51 Pegasi. It was a milestone that opened a floodgate. Since then, with the help of powerful telescopes like Kepler and TESS, we have discovered thousands of exoplanets, over 5,000 confirmed so far, with more being added every month. Some are gas giants larger than Jupiter, orbiting so close to their stars that their years last only a few days. Others are frozen worlds, orbiting faint red dwarfs. Some may even be rocky planets, similar in size and temperature to Earth. Astronomers have a special interest in planets within the so-called habitable zone, the region around the star where liquid water could exist. Water is essential for life as we know it, and finding it elsewhere would be a step toward answering one of humanity's oldest questions. Are we alone? Already, candidates have appeared. Planets like Kepler 452b, sometimes called Earth's cousin, orbit their stars at just the right distance for water. The TRAPPIST-1 system, with 7 rocky planets, has drawn special attention. 3 of those worlds lie within the habitable zone of their star. Though we don't yet know if they have oceans or atmospheres, they remind us that Earth may not be unique. Technology is now advancing to let us study these worlds in greater detail. The James Webb Space Telescope, launched in 2021, can analyze the atmospheres of exoplanets by capturing starlight as it filters through them. By studying the light, scientists can look for chemical fingerprints, signs of oxygen, methane, or even water vapor. One day, these observations might reveal not just habitable planets, but inhabited ones. The idea that we may not be alone in the universe is as old as humanity itself. Every culture has looked up at the stars and wondered if there are others out there. For now, we have only questions, but each exoplanet discovery brings us closer to answers. Think of this. Every star you see in the night sky could have planets around it. Worlds of oceans, deserts, mountains, and storms. Some may be lifeless. Others may hold strange forms of life, plants, creatures, or even civilizations looking back at the stars as we do. The universe is vast, and our search has only just begun. Part 6. The Secrets of the Solar System. We often dream of distant galaxies and mysterious exoplanets, but the truth is our own solar system is filled with wonders beyond imagination. If you enjoy this cosmic journey, remember to like this video and subscribe. More stories are on their way. The solar system is a family of worlds, bound together by the gravity of our sun. At the center burns the star that gives us life, a steady furnace that has shone for 4.6 billion years and will continue for billions more. Around it orbit 8 planets, more than 200 moons, countless asteroids, comets, and icy bodies. Each one tells its own story. Closest to the sun lies Mercury, a small rocky world where daytime temperatures can melt lead and nights plunge into freezing cold. Next comes Venus, Earth's twin in size, but not in spirit. Wrapped in thick clouds of carbon dioxide, it is the hottest planet in the solar system, with surface temperatures hotter than an oven and pressures that could crush a submarine. Then, Earth, the blue planet, the only world we know with life. Oceans, forests, skies, and all of us spinning quietly in the darkness. Our moon orbits nearby, guiding tides and illuminating the night. Without it, Earth's tilt might wobble wildly, and life could have struggled to find stability. Beyond Earth lies Mars, the red planet. Dry and cold today, but ancient riverbeds tell us it once had flowing water. Some scientists believe that billions of years ago, Mars might have been more Earth-like, with lakes and perhaps even life. Robotic explorers like Curiosity and Perseverance are searching for clues, while humans dream of one day walking its rust-colored plains. Further out, the gas giants reign. Jupiter, the largest planet, is a swirling giant of storms, home to the Great Red Spot, a hurricane 3 times the size of Earth that has raged for centuries. Its moons are miniature worlds themselves. Europa, with an icy crust hiding a vast ocean beneath. Ganymede, the largest moon in the solar system. Io, covered in erupting volcanoes. Each could hold secrets of life or geology unlike anything we've seen. Saturn follows, adorned with its breathtaking rings of ice and rock. Though thin and delicate, the rings stretch across hundreds of thousands of kilometers, making Saturn one of the most beautiful sights in the sky. Its moon Titan has thick orange clouds and lakes of liquid methane, while Enceladus shoots geysers of water into space, a possible sign of an ocean beneath. Beyond Saturn lies Uranus, tilted on its side, rolling around the sun like a spinning ball. Its pale blue color comes from methane in its atmosphere. Neptune, the farthest giant, is a deep azure world of fierce winds and storms. And far beyond them all, the Kuiper Belt, a region of icy bodies, comets, and dwarf planets like Pluto, Eris, and Haumea. The solar system does not end there. The Oort cloud, a vast shell of icy fragments, may surround us at a distance so great it takes light a year to cross. From time to time, one of these icy bodies falls inward, becoming the comets we see streaking across our skies. Every world in the solar system is unique, and together they form a cosmic neighborhood still full of mysteries. Though we have sent probes to many planets, much remains unexplored. Beneath the icy crusts of Europa and Enceladus, in the methane lakes of Titan, or deep under Mars's soil, life may yet be hiding. And even if Earth is alone in its life, the solar system reminds us of the fragile balance that made our world possible, a balance that could have easily been different. Part 7. Time, Light, and the Edge of the Universe. If you're enjoying this story, don't forget to like this video and subscribe. More cosmic journeys are waiting. When you look at the stars, you are not seeing them as they are now, but as they were long ago. Light takes time to travel, and the universe is vast. The light from the moon takes just over 1 second to reach us. Sunlight takes about 8 minutes to reach us. The light from the nearest star, Proxima Centauri, takes over 4 years. And when we look at the Andromeda galaxy, we're seeing it as it was more than 2 million years ago. Every glance into the night sky is a look back in time. The farthest light we can see comes from the edge of the observable universe, the cosmic microwave background, the faint glow left over from the Big Bang nearly 13.8 billion years ago. This ancient radiation is like a baby picture of the cosmos, showing us the universe as it was when it was just 380,000 years old. It surrounds us in every direction, whispering of beginnings too distant to truly imagine. But light is not just a messenger of time. It is also bound by the deepest laws of physics. According to Einstein's theory of relativity, nothing can travel faster than light. It sets the ultimate speed limit of the universe. But relativity also tells us something stranger. The faster you move, the slower time flows for you. This is not theory alone. Astronauts on the International Space Station, moving at 28,000 kilometers per hour, age slightly more slowly than people on Earth. The difference is tiny, but real. In the extreme environment near a black hole, time itself stretches almost to a stop. To an outside observer, a falling object appears to freeze at the event horizon, never truly crossing. Inside, however, the object continues, though what happens next remains hidden behind the veil of relativity. The expansion of the universe also bends our sense of time and distance. Galaxies are not simply moving through space. Space itself is stretching, carrying them farther away. Some galaxies are already beyond our reach. Their light, stretched into infrared by cosmic expansion, will never arrive. The observable universe is about 93 billion light-years across, but beyond it may lie infinite space, forever beyond our sight. This raises profound questions. Is there an edge to the universe? If space goes on forever, what does infinity truly mean? Or if the universe is finite, what lies beyond it? These are questions no telescope yet can answer. But every observation, every photon of light captured by our instruments brings us closer. In a way, the universe is a great time machine. The stars above us show not just beauty, but history. When you look at the sky, you are witnessing a story billions of years old, still traveling toward your eyes at the speed of light. And perhaps the greatest mystery is this. If we're looking back in time every time we gaze at the stars, what stories from the future might the universe be waiting to tell? Part 8. The Future of the Universe. If you've enjoyed the journey so far, remember to like this video and subscribe. Your support helps keep these cosmic stories alive. The universe has a beginning, but does it have an end? This question haunts astronomers and philosophers alike, and while no one can know with certainty, science has given us several possible futures. Right now, we know the universe is expanding. Galaxies are rushing away from one another as space itself stretches. For much of the 20th century, scientists debated whether this expansion might someday slow, perhaps even reverse, leading to a big crunch, a collapse where all matter falls back together, returning to a hot, dense state like the Big Bang in reverse. But in the late 1990s, astronomers discovered something unexpected. By studying distant supernovae, they found that the expansion of the universe is not slowing down, it's accelerating. Some mysterious force, which we call dark energy, is pushing galaxies apart faster and faster. If this continues, the universe may face a heat death. Over trillions of years, stars will burn out, galaxies will fade, and only black holes will remain. Even they will eventually evaporate through Hawking radiation, leaving behind a dark, cold, empty cosmos. Time itself would stretch endlessly, but nothing would remain to witness it. There are other possibilities. Some theories suggest a big rip. If dark energy grows stronger with time, it could eventually tear galaxies, stars, planets, and even atoms apart. The very fabric of space-time could unravel, ending the universe in a final, violent moment. Another idea is the Big Bounce. Perhaps the universe expands until it cannot stretch further, then collapses back only to explode outward again in another Big Bang. If true, we might be living in just one cycle of an eternal cosmic heartbeat, where universes rise and fall forever. Beyond these grand endings lies one more mystery, the multiverse. Some cosmologists suggest our universe may be just one bubble among countless others. If so, new universes could be born, even as ours fades. What lies beyond our cosmic horizon may be stranger than we can imagine. Worlds with different laws of physics, different stars, different possibilities. And yet, despite all these predictions, we live in a fleeting moment of cosmic brightness. Stars still shine, galaxies still glow, life has emerged, at least here, to gaze upward and ask questions. For now, the universe is alive with energy, and our time within it is more precious because it is temporary. Perhaps the most beautiful truth is this: no matter how the universe ends, every moment we live is part of its story. We are made of stardust, born in the fires of long-dead stars, and when we look to the future, we are really looking into the mirror of our own fate. The cosmos is not only out there, it is within us. Its future is our future. Part 9. The Search for Other Worlds. If you're enjoying this journey through the universe, don't forget to like this video and subscribe. More cosmic stories are coming to help you dream among the stars. For centuries, humans looked at the night sky and wondered if other worlds like Earth might exist. For a long time, it was only imagination. But in the last few decades, that dream became reality. Astronomers discovered that planets around other stars, exoplanets, are not rare at all. In fact, they're everywhere. The first confirmed exoplanet was discovered in 1992, orbiting a pulsar, the dense dead remnant of a star. A strange place for planets to exist. But in 1995, a new discovery changed everything. A giant planet orbiting a sun-like star. Since then, we have confirmed more than 5,000 exoplanets, and the number keeps growing. Some of these worlds are hot Jupiters, massive gas giants that orbit so close to their stars they are scorched at thousands of degrees. Others are frozen giants, far from warmth. But among them are rocky planets, some roughly the size of Earth, lying in the habitable zone, not too hot, not too cold, where liquid water could exist. One of the famous discoveries is the TRAPPIST-1 system, with 7 Earth-sized planets orbiting a small, cool star just 40 light-years away. At least 3 of those planets lie in the habitable zone. Imagine a sky where other worlds are so close that they appear larger than our moon, entire planets hanging above the horizon. With telescopes like the James Webb Telescope, we are now beginning to study the atmospheres of these distant planets. By analyzing the light that passes through an exoplanet's atmosphere as it crosses its star, scientists can detect gases like water vapor, carbon dioxide, and even methane, possible fingerprints of life. The ultimate question is, are we alone? Life on Earth began surprisingly quickly after the planet formed, suggesting that life might also emerge easily elsewhere. Yet, we have not found direct evidence. The silence of the universe is sometimes called the Fermi paradox. If life is common, why haven't we seen signs of it? Some answers may lie on nearby worlds. Mars, Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, may all hold clues. Frozen oceans beneath thick ice could hide microbes or even something more complex. Each discovery brings us closer to knowing. If we find even the simplest life elsewhere, it will mean Earth is not unique. It will mean the universe is filled with possibilities. If we find nothing, it will make our own existence even more extraordinary, a fragile flame in the vast dark. Either way, the search for other worlds is also a search for ourselves, for in discovering whether we are alone, we discover what it means to exist. Part 10: Humanity's Journey Beyond Earth. If you've enjoyed traveling through the universe with us, don't forget to like this video and subscribe. More cosmic stories will continue to guide you among the stars. For thousands of years, humans dreamed of touching the heavens. We watched the moon, the planets, and the distant stars, imagining what might lie beyond. But only in the 20th century did those dreams begin to take shape. It started with rockets, simple, powerful machines that could break free of Earth's grip. The first successful rockets were humble, small, and experimental, but they paved the way for something far greater. In 1957, the Soviet Union launched Sputnik 1, the first artificial satellite to orbit Earth. A tiny metal sphere, no larger than a beach ball, changed the world forever. Humanity had entered space. Just 4 years later, Yuri Gagarin became the first human to orbit the planet. He circled Earth in a spacecraft called Vostok 1, witnessing the world from above, a fragile blue marble suspended in the blackness. His famous words, "I see Earth, it is beautiful," captured the awe and humility of the first human perspective beyond our world. The space race soon took us further. The Apollo program landed humans on the moon in 1969. Neil Armstrong and Buzz Aldrin walked on the lunar surface, leaving footprints that might last millions of years. For the first time, humans had set foot on another world. Gazing back at Earth, a glowing orb of oceans and clouds in a sky of endless black. Since then, humanity's presence in space has grown steadily. Space stations orbit our planet. Astronauts live for months at a time, conducting experiments that would be impossible on Earth. Robots explore Mars, Titan, and distant asteroids, sending back images that astound and inspire. We are now on the cusp of a new era. Private companies plan to send humans to Mars. Scientists are designing ships that could travel to other star systems within our lifetimes, or perhaps our grandchildren's lifetimes. The dream of walking among the stars is no longer fantasy. It is a challenge we are beginning to meet. But space is not just a place to explore physically, it is also a mirror. When we see Earth from orbit, we understand its fragility and beauty. When we imagine the universe beyond, we confront our smallness and our potential. Every mission, every telescope, every discovery reminds us that the cosmos is vast, mysterious, and waiting. Humanity's journey beyond Earth is just beginning. One day, our descendants may live among the stars, stepping onto planets orbiting other suns, witnessing alien skies, and perhaps finding life in forms we cannot yet imagine. For now, we can dream, explore with our minds, and let the stars guide us. The universe is immense, but it has welcomed us to begin our journey. And as long as we look up, we will continue to reach outward, toward the infinite.